Hey 910. Today we are going to be starting our new project on gas laws. Now for your project, you're going to be taking the information that is on the notes, on the activities, on the labs, and your own research and explaining real world phenomena on gas laws. Now I have a separate document and a separate video explaining everything for your project. So please, after the notes today and after you're done with the worksheet, please take a look at it and start doing your research. So what we're going to do today is as follows. First thing is I want to introduce you to gas laws. That's going to be the first thing that we are going to do today. The second thing is we're going to be learning how to convert between the temperatures, because something really important with gas laws and how you can explain a lot of the gases is just by what temperature it is at. The third thing you have today is working on a worksheet on converting temperatures. When you're done with that worksheet, if you have not gotten done with your previous project, please get it done with the remaining time you have today. If your last project is already done and turned in, then please start to research your gas project, okay? Awesome. So without further ado, I want to give you guys a nice introduction to gas laws. It is my favorite way of starting gas laws, and I think it's going to be your favorite too. So how many of you guys have ever driven in a car after getting pizza and you just smell the pizza and you're like, oh my god, I cannot wait to eat this pizza? Or if somebody's baking your house and you can smell the cookies being baked or smell the cake being baked, or your parents are cooking dinner, or even better, you're cooking dinner and you just smell it and you're like, oh my god, this smells so good. I really just want to start digging in and eating it right here, right now. Well, I have good news for you. When you are smelling those smells, you're actually eating part of it. When you smell in those gas particles coming up off that food, you're actually ingesting. Isn't that cool? Now here is the part where you guys are gonna hate me a little bit. So that being said, that you're smelling things, you can actually eat them, you're actually ingesting them. That's fun. But how many of you guys have siblings? Maybe it might be your parents, or in public, and you got into the bathroom, and you just walk in the bathroom, and you just smelled the most horrible smell ever. You're like, oh my god, what did they do in this bathroom? Well, when you're smelling the bathroom, it's the same thing as smelling that food. And yep, you're eating it. You're ingesting some of those gas particles in that bathroom. And on that note, let's start our notes today. So, introducing gas laws. When we study gas laws, we'll be investigating how gases behave when they're under pressure in a closed system. We're going to be keeping this at first in a closed system. Now, what is a closed system, might be asking? Well, a closed system is one with a constant amount of moles of a substance, therefore it is not open to the atmosphere. This is like a box that is locked away. You have your box and nothing get in or out. We call that a closed system. I'm going to be using it a lot in our gas laws and our math because the closed system keeps everything constant. If we had an open system, we would have to be calculating the different amount of moles every single second, and that would be very, very hard to do. Now, other key concepts we're going to care about gas laws with is the average pressure of the atmosphere. Now, we're going to be most of the time keeping it at sea level. And at sea level, the standard pressures are as follows. You can use any of these to convert between any of them because they are equal to one another. You can use 760 millimeters of mercury, or 760 torr, 1 atmosphere, or 101.3 kilopascals as our pressure units. Depending on what we're working with, we'll be using all of these or some of these. This 1 millimeters of mercury was actually how old-time thermometers used to work. They actually had mercury inside there, and as you heat it up, it would increase the pressure, making it go up, which is kind of cool. Now you can use the following when converting units of pressure from millimeters of mercury to torr to atmospheres or kilopascals in whichever order you need. We'll be covering these conversions at a later date. I just want to get you guys feet wet with just a little bit of converting on there first. Now here's something that is super cool. STP. Now the freezing point of water is 0 degrees Celsius or 273 degrees Kelvin. Now you might not know what this Kelvin scale is. We're going to be, if you don't know what it is, we're going to be exploring it today, as well as throughout this whole entire project, and is defined as a standard temperature. Now if we combine both the pressure and temperature, we can combine these to form a pressure and temperature scale, and we have something referred to as the standard temperature and pressure, or STP. Now standard temperature and pressure is at room temperature and at 1 atmosphere. So at 60 degrees Fahrenheit is usually the temperature we set at America, and at 1 atmospheric of pressure. That's usually when we make these calculations, that is what we're going to be using. We can always change the temperature, and if we change the temperature, we are going to be changing the pressure, but we'll get into that equation at a later time. The other one we're going to be using is the normal conditions under which we live, which are referred to as the standard ambient temperature and pressure, or the SATP, which is defined as 20 degrees Celsius or 100 kilopascals. This is the one that is going to be changing depending on where you live and what situation you are going to be in. Now, something that is really cool that a lot of people mistake is temperature units in absolute zero. Absolute zero isn't defined as 0 degrees Celsius or 0 degrees Fahrenheit. They're not considered absolute zero. In fact, temperatures can go well below those numbers, and we can achieve those really cold numbers. A lot of times we get below 0 degrees Fahrenheit in our wintertime. You guys have all been outside when it was negative some degrees Fahrenheit during the winter. So getting below these 0 degrees Celsius and degrees Fahrenheit is not considered absolute zero. Absolute zero is defined as precisely 0 degrees Kelvin on the Kelvin scale, which is a thermodynamic, that means absolute, temperature scale. Whenever you do anything in our gas laws, we're going to be using the Kelvin scale because it gives us a definite ending point and definite starting point. Now, the temperature on the scale is going to be, if you're looking at degrees Celsius, is negative 273.15 degrees Celsius. And we're going to learn how to convert this in a second. So last thing we're going to be doing is we're going to be practicing unit conversions. Now on here are all the conversions we're going to be doing. We have 2 sets of unit conversions that we're going to be doing. One is converting Kelvin to Celsius, and the other one's going to go from Celsius to Fahrenheit. And we can do the opposite in each one. Go from Kelvin to Celsius and Fahrenheit to Celsius as well. Now for this, I want to show you guys some examples before you guys go into the worksheets. So please pay attention, and if you need to come back to this video to replay it, please feel free. So on here, I have some examples for us to do. Let me recenter my camera. I'm sorry about that. Okay. So for this first one, we're going to talk about converting Celsius to Kelvin. Now, if you remember, or you just need to go back, our conversion between Celsius to Kelvin is this equation here. Temperature in degrees Kelvin is equal to temperature degrees Celsius plus 273.15. So knowing this, we could use this equation to find out our Kelvin value here. So we're asking for Kelvin, so our first one is going to stay the same. Our temperature of Kelvin is going to stay there. Now, do we know our degrees Celsius from our question? Yes, we have our degrees Celsius right here. So we can plug in 94 degrees Celsius here. Now we're going to add this to 273.15. Now when we do this, what we're going to do is we're going to add them together to find our answer. So our degrees Kelvin is just 94 plus 273. Please feel free to pause this video and solve this. You can use a calculator if you want. So take a second, pause the video, and write down your answer in the question following this. Alright, so you should have gotten, after adding them together, 367.15 degrees Kelvin as your answer. Now, the next one we're going to be doing is we're going to be doing degrees Kelvin to Celsius. For this, what we're going to be doing is just reversing it. So instead of starting off with degrees Kelvin, we're going to be starting off with our degrees in Celsius. Now, if you remember from before, or you need to go back and look at the equation again, our equation is temperature in degrees Celsius is equal to temperature of Kelvin minus 273.15. So again, we're going to follow in and plug what we know. Do we know our degrees Celsius? No, we don't. So we're going to put temperature degrees Celsius is equal to, do we know our degrees Kelvin? Yes, we're given it right here. So we know it's equal to 563 degrees Kelvin minus 273.15. So again, I would please ask you to pause the video, use a calculator, and find what this equals. Alright, so you guys should have gotten our degrees Celsius as 289.85 degrees Celsius. For our last two questions, we're going to be looking at converting between Celsius to Fahrenheit. Now, these ones are a little bit more complicated, just because the equation looks a little bit more difficult. So in this case, we have our degrees Celsius times 9 divided by 5 plus 32. So for these, what we're going to do is we're going to plug in what we know. So what do we know here? Well, we know our degrees Celsius because it's given to us in our question of 42 degrees Celsius, and we're trying to find Fahrenheit. So we can plug in 42 times 9 divided by 5 plus 32. Now it is important that you do this step first. This is an important step to do first here. Otherwise, you'll get the wrong answer. So using your calculator, you do 42 times 9 divided by 5. In this case, you should get 75.6. You add 32 to it. What do you get when you do 75.6 plus 32? Well, it's equal to 107.6 degrees Celsius. All right, time for our last question. Our last question here is going from degrees Fahrenheit to degrees Celsius. So how we do this is we're going to just follow our equation from the video before. So in here, we're going to be following this equation. Degrees Fahrenheit minus 32 times 5 divided by 9. So in this case, we are starting off with 98.5 degrees Fahrenheit. So we can start off by saying 98.5 minus 32, I'll make parentheses same color again, times 5 divided by 9. So again, you always do the parentheses first. Please, 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 always do parentheses first. So 98.5 minus 32 should give you 66.5. We're going to multiply that by 5 and divide by 9. So what do you get as your final answer? You should have gotten 36.94, or if you want to round it, you can say 37 degrees Celsius. That's all we're going to be doing for today. So if you could please work on the practice for this, as well as getting your project started and working on all that other stuff, I would greatly appreciate it. If you need any more help, please feel free to drop by my office hours. I'll have them at 1 o'clock, like always. So if you want to just hang out and do some work, if you need some extra help, or anything at all, please feel free to contact me or drop by at 1 o'clock at our meeting. Any case, guys, thanks for coming on. Thanks for learning a little bit of gas laws today, and hope you guys enjoyed it and have a wonderful night. Goodbye, guys.